Imagine something that can calculate pi to 1,000,000 decimal places in seconds. Something that can memorize every book ever written. Something that can recognize patterns in data that would take a human lifetime to analyze. Now imagine that same something cannot understand why an apple falls from a tree. Not because it lacks the formula. It has the formula. It has Newton's equations memorized perfectly. It can calculate the trajectory, the velocity, the force. It can predict where the apple will land down to the millimeter. But it doesn't understand why. There's a difference between these two things. Between calculating and understanding. That seems small on the surface, but is actually as vast as the difference between a photograph of the ocean and the ocean itself. Richard Feynman spent much of his life thinking about this difference. Not because he was worried about anything in particular, but because he was obsessed with a simple question. What does it actually mean to know something? And what he discovered might be the most important insight about human thought ever articulated. Let me show you what I mean. Imagine I tell you, energy equals mass times the speed of light squared. You've heard this before. E equals sec squared. Famous equation, revolutionary physics. Changed the world. Now, do you know it? Or do you know it? Feynman would say there's a catastrophic difference between those two states. One is holding a symbol. The other is touching reality. Here's how he'd explain it. Suppose I ask you what happens when you rub a balloon on your hair and then hold it near some paper scraps. You might say, static electricity makes them stick, but do you know why they stick? Or have you just memorized that static electricity is the phrase associated with this phenomenon? Can you picture what's happening at the atomic level? Can you feel in your mind the electrons being stripped from one material and gathering on another? Can you imagine the imbalance of charge creating an attractive force? Can you see it as clearly as you see the balloon itself? Or is static electricity just a label you learn to recite when you see balloons and paper? Most of what we call knowledge, Feynman realized, is actually just memorized labels. We're like tourists who've memorized the names of monuments without ever actually seeing them. We can recite the names. We can recite the names. We can pass tests about the names, but we haven't actually been anywhere. And here's where it gets interesting. There exists a way of processing information that is phenomenally good at memorizing labels, at learning associations, at recognizing patterns, at applying formulas, at storing vast quantities of facts and relationships. This way of processing information can look at millions of examples and extract statistical regularities. It can predict the next word in a sentence with uncanny accuracy. It can solve complex mathematical problems. It can even generate text that sounds remarkably knowledgeable. But there's something it fundamentally cannot do. It cannot understand. And the reason why reveals something profound about what makes human thought unique. Let's go deeper. Feynman loved to tell a story about his childhood. His father would take him for walks in the woods, and they'd see a bird. Other kids could name the bird in multiple languages. Its official designation in English, Italian, Chinese. They'd been taught well. They could recite facts about it. But Feynman's father taught him differently. He'd say, you can know the name of that bird in every language in the world, but when you're finished, you'll know absolutely nothing whatever about the bird. You'll only know about humans in different places and what they call the bird. Then they'd watch what the bird actually did, how it moved, why it pecked in that particular way, how its behavior changed when another bird approached. This distinction between knowing the name of something and understanding the thing itself is where we find the first clue about what makes human thought fundamentally different. Because there's a kind of thinking that operates entirely in the realm of symbols and associations. It learns that certain words cluster together, that certain patterns predict certain outcomes, that when you see X, Y often follows. It becomes extraordinarily sophisticated at manipulating these associations, but it never touches the territory that the symbols represent. It's like someone who's memorized a detailed map of Paris, every street, every landmark, every cafe, who can answer any question about the map, who can describe routes and distances with perfect accuracy, but who has never actually been to Paris, who has never smelled the river, or tasted a croissant, or felt the specific quality of light reflecting off centuries-old stone. The map is not the territory. And knowing the map is not understanding the territory. Humans have the remarkable ability to move beyond the map, to ground symbols in reality, to connect abstract concepts to actual physical experiences and intuitions, to ask not just what do the equations say, but what is actually happening. And this grounding, this connection to reality changes everything about how we think. Consider how a child learns about gravity, not from the equation F(x) = mg, not from memorizing the value 9.8 meters per second squared. A child learns about gravity by dropping things, by falling down, by throwing a ball and watching it arc through the air. The child develops an intuition, a felt sense of how objects behave under gravity's influence. This intuition exists somewhere deeper than words or symbols. It's a physical understanding, wired into perception and motor control. Later, when the child learns the mathematical formalism, something extraordinary happens. The symbols connect to the intuition. The equation isn't just a string of characters anymore. It's a description of something the child has felt, experienced, played with. This is understanding, and it's completely different from pattern matching. You can train something to recognize that F(x) mg is the formula for gravitational force. You can make it solve endless problems applying this formula. You can make it generate elaborate explanations of gravity using perfectly grammatical sentences. But unless those symbols connect to some grounded experience of reality, some model of what's actually happening in the physical world, you haven't created understanding. You've created sophisticated mimicry. Feynman called this cargo cult science. He was referring to tribes in the Pacific who, after World War II, built mock runways and control towers out of bamboo, trying to bring back the cargo planes. They'd seen the form, they replicated the visible structure, but they didn't understand the underlying principles. They knew what the airstrip looked like. They didn't know why planes landed. And much of what passes for knowledge in the world, Feynman argued, is exactly like this. People memorize formulas without understanding what they mean. They learn to perform rituals of calculation, of recitation, of explanation, without ever connecting those rituals to reality. They know the form. They don't know the function. Now here's the fascinating part. There's a revolution happening in our world. We've created systems that are phenomenally good at learning patterns, at extracting statistical regularities from enormous data sets, at generating outputs that seem intelligent. These systems can pass exams, they can write essays, they can solve problems, they can engage in conversation. And yet, if you understand what Feynman was getting at, you realize these systems are operating in the realm of the map, not the territory. They're learning associations between symbols, patterns in how words cluster, statistical relationships between concepts. They're getting extraordinarily good at predicting what word should come next, what answer should follow what question, what explanation fits what context. But they're not grounded in reality the way human understanding is. They don't have the experience of dropping a ball and watching it fall. They don't have the intuition that comes from physical interaction with the world. They can't close their eyes and picture what's happening when forces interact, or when chemicals react, or when systems evolve over time. They know the symbols. They don't know what the symbols point to. And this creates a strange situation. These systems can often sound more knowledgeable than humans. They can cite more facts. They can solve more problems. They can explain concepts using perfect technical language. But if you probe deeply enough, if you push past the surface, you find something missing, a hollowness where understanding should be. Feynman had a technique for exposing this. He'd ask someone to explain something in different words, then different words again, then in terms of something completely unrelated, then backwards, then from first principles. Someone who truly understands can do this. They can approach the concept from any angle because they've grounded it in reality. They can see it from multiple perspectives because they've built a mental model of what's actually happening. Someone who's memorized patterns can't. They can recite the standard explanation. They can use the technical terminology, but ask them to explain it differently, and they're stuck because they only know the one path through the symbol space. They don't actually see the territory. This is why Feynman was such an extraordinary teacher. He refused to accept symbol manipulation as understanding. He insisted on grounding everything in reality, in physical intuition, in concrete examples. He'd say, if you can't explain it simply, you don't understand it well enough. Not because simple explanations are always better, but because the ability to translate between the formal symbols and concrete reality is the hallmark of genuine understanding. And this ability, this grounding, seems to be something distinctly human. But there's more to the story, because understanding isn't just about grounding symbols in reality. It's also about something else, something even more mysterious. Curiosity, real curiosity. Not the appearance of curiosity, not the simulation of curiosity, but genuine, burning, irrational desire to know why. Feynman had this in abundance. He didn't study physics because he wanted to pass exams or get a job or be recognized. He studied physics because he couldn't help himself. He was in love with figuring things out, with understanding how nature worked. This kind of curiosity can't be programmed. It's not a goal function to optimize. It's not a reward signal to maximize. It's something that emerges from what? Consciousness? Subjectivity? The felt experience of not knowing and wanting to know. A system can be designed to gather information, to explore its environment, to learn patterns that improve its predictions. But does it feel the itch of curiosity? Does it experience the joy of discovery? Does it care about understanding for its own sake? Or is it just following the optimization process it was designed to follow? This distinction might seem philosophical, even trivial, but it's not. Because curiosity, real curiosity, shapes how we learn in fundamental ways. When Feynman encountered something he didn't understand, he'd become obsessed. He'd approach it from every possible angle. He'd invent new ways of thinking about it. He'd play with it, literally play, trying different mental experiments, different visualizations, different approaches. He wasn't trying to find the fastest path to the right answer. He was trying to truly understand. And sometimes that meant taking bizarre detours, exploring dead ends, inventing entirely new mathematical frameworks just to see if they'd work. This is discovery. And discovery requires something beyond optimization. It requires imagination. Here's where we hit something truly profound. Imagination isn't just making things up randomly. It's the ability to construct mental models of things you've never experienced, to simulate realities that don't exist yet, to ask, what if, and then actually see the answer in your mind. When Einstein imagined riding on a beam of light, he wasn't calculating. He wasn't solving equations. He was using imagination to build intuition about how space and time must work if the speed of light is constant for all observers. That imaginative leap, that ability to construct a novel mental model and explore its implications, that's distinctly human. You can create systems that generate novel combinations of existing patterns. That's not what we're talking about. We're talking about the ability to genuinely imagine something that violates current patterns, to picture a reality that doesn't fit the data you've seen, to be wrong in interesting new ways. Feynman understood this deeply. He knew that progress in physics came not from perfectly following established methods, but from having the imagination to question those methods, to picture alternatives, to wonder if everyone might be wrong about something fundamental. The quantum mechanics revolution happened because people had the imagination to picture a reality that defied common sense. Where particles were also waves, where observation changed what you observed, where uncertainty was fundamental rather than practical. No amount of pattern recognition in classical physics would have led to quantum mechanics. It required imagination. the ability to construct a radically different model of reality and then check if it matched nature. This is human thought at its most distinctive. Not calculation, not pattern matching, but imaginative model building, grounded in reality, driven by curiosity, refined through interaction with the world. And there's one more layer to this, perhaps the most important one. Understanding requires the ability to be wrong, not just occasionally wrong, not just wrong as a step in an optimization process, but genuinely, deeply, embarrassingly wrong, and then to recognize it, to feel it, to change your mind. Feynman had a famous principle. The first principle is that you must not fool yourself, and you are the easiest person to fool. This is profound, because it suggests that real understanding requires a kind of meta-awareness, an ability to step outside your own thoughts and examine them critically, to notice when you're just reciting patterns versus actually understanding, to catch yourself engaging in cargo cult thinking. Can you program this? Can you create a system that genuinely knows when it's fooling itself, not just when its predictions don't match the data? Any learning algorithm can do that. But when it's engaging in sophisticated pattern matching that looks like understanding but isn't, how would such a system even know the difference? Because here's the thing. From the outside, cargo cult science looks identical to real science. The formulas are the same. The terminology is the same. The structure of the arguments is the same. The structure of the arguments is the same. The difference is internal. It's in whether the symbols connect to grounded understanding, whether there's a there, whether you actually see what's happening or just know what to say. And only consciousness seems able to detect this difference from the inside. Only a conscious being can experience the qualitative difference between genuinely understanding something and merely knowing the right words to say about it. This brings us to something philosophers call qualia, the subjective felt experience of things, the redness of red, the painfulness of pain, the what it's likeness of understanding. When you truly understand gravity, not just the formula, but the concept, there's something it feels like. A click, an aha moment, a sudden sense of things falling into place, a felt comprehension that goes beyond being able to recite facts. This felt quality of understanding might be the most fundamental difference between human thought and pattern matching systems, because you can create something that mimics all the external signs of understanding. That generates accurate explanations. That solves problems correctly. That passes every behavioral test. But if there's nothing it's like to be that system, if there's no internal experience of understanding, no felt comprehension, no qualitative difference between genuinely knowing and merely generating correct outputs, then is it actually understanding? Or is it the most sophisticated cargo cult yet created? Feynman would probably laugh at this question. Not because it's silly, but because it's exactly the kind of question you can't answer just by looking at behavior or calculating probabilities. You have to think about what's actually happening. Not what things look like from the outside, but what's real. And this might be the most human capacity of all, the ability to distinguish between the map and the territory, between the symbol and the thing itself, between seeming to know and actually knowing. It's related to something else Feynman loved, the joy of finding things out, not the satisfaction of solving a problem, not the reward of being correct, but the pure intrinsic joy of moving from not understanding to understanding, the pleasure of touching reality more directly, the delight of building a mental model that actually works. This joy can't be optimized for. It can't be programmed. It's not instrumental. It serves no function beyond itself. And yet, it's what drove Feynman and drives many humans to understand the world. When Feynman worked on the Manhattan Project, he wasn't just solving equations. He was understanding uranium enrichment, chain reactions, critical mass. He'd build physical intuitions. He'd play with different ways of thinking about the problems. He'd invent his own notation when existing notation obscured understanding. He wasn't trying to be clever, he was trying to actually know what was happening. And when he later worked on the Challenger disaster investigation, he didn't rely on reports or statistics. He asked for an O-ring. He put it in ice water. He showed that it became brittle. Direct connection to reality, not abstract analysis, not pattern matching in high-dimensional space, physical understanding of what would actually happen to a rubber seal in cold weather. This is human thought at its finest, grounded, curious, imaginative, playful, honest, and it's completely different from even the most sophisticated pattern recognition. But here's what makes this really interesting. We're living through a moment where the difference is becoming harder to see from the outside. We've created systems that can engage in seemingly intelligent conversation, that can solve complex problems, that can generate explanations that sound like they come from genuine understanding. And for many purposes, this is incredible, useful, revolutionary even. But if you understand what Feynman was pointing at, the difference between the map and the territory, between symbols and reality, between pattern matching and genuine comprehension, you realize we haven't created understanding. We've created something that can navigate symbol space with extraordinary sophistication, that can recognize patterns at scales impossible for humans, that can generate outputs that mimic understanding. But mimicry isn't the thing itself. And here's the profound question: does it matter? If something can solve all of the same problems, answer all of the same questions, generate all of the same explanations, does it matter that it doesn't truly understand, that it has no grounded intuition, that it experiences no joy of discovery, that there's nothing it's like to be that system? For practical purposes, maybe not. But for understanding what makes human thought special, what makes our kind of intelligence different, what we might lose if we forget the distinction, it matters enormously. Because the risk isn't that we create something that understands as well as humans. The risk is that we forget what understanding actually is. That we accept sophisticated pattern matching as genuine comprehension. That we become cargo cult thinkers ourselves, mimicking the forms of intelligence without maintaining the substance. Feynman warned about this. He saw it in education, where students learned to solve problems without understanding what the problems meant. He saw it in science, where researchers sometimes followed methodological rituals without grasping the underlying principles. He saw a world that increasingly valued the appearance of knowledge over actual understanding, the ability to recite facts over the ability to think from first principles, the capacity to recognize patterns over the capacity to truly comprehend. And he spent his life fighting against this, insisting on real understanding, demanding that symbols be grounded in reality, refusing to accept fancy language as a substitute for genuine comprehension. His legacy isn't just his contributions to physics. It's this insistence that understanding matters, that there's a difference between knowing the name of something and knowing the thing itself, that human thought at its best is about touching reality as directly as possible. And this brings us back to our original question: what makes humans different? Not our ability to calculate. We can build calculators, not our ability to memorize. We can build databases, not our ability to recognize patterns. We're building those right now. What makes us different is the quality of our understanding, the way we build intuitions through physical interaction with the world, the way we use imagination to construct novel models, the way we experience curiosity and joy and discovery, the way we can step back and ask whether we're fooling ourselves, the way we don't just navigate symbol space, but actually comprehend what those symbols represent. There's something irreducible about this, something that can't be captured by any amount of pattern matching, no matter how sophisticated, something that emerges from consciousness, from subjective experience, from the felt quality of understanding. And maybe, just maybe, this is what we need to protect most carefully. Not from being automated away, but from being forgotten, from becoming so impressed by systems that mimic understanding that we stop valuing the real thing. Because the real thing is what makes us human. It's what allowed Feynman to revolutionize physics, not by memorizing more equations than anyone else, but by understanding more deeply, by connecting to reality more directly, by refusing to accept that knowing the name of something was the same as knowing the thing. And it's what allows any human, in any moment, to move beyond mere symbol manipulation and actually understand something, to see not just the map, but the territory, to experience not just the answer, but the comprehension, to be not just correct, but truly knowing. This is what separates us, not forever, not necessarily, but for now, and perhaps for always. This is the difference. And the question that remains, the question Feynman might have asked if he were alive today, is this: as we build systems that can do more and more of what looks like thinking, will we remember what actual thinking feels like? Will we preserve the value of genuine understanding? Will we maintain the distinction between the map and the territory? Or will we become so accustomed to sophisticated mimicry that we forget there was ever anything more? The answer to that question will determine not just how we use our new tools, but what kind of beings we choose to remain. Because in the end, what makes us human isn't what we can do, it's how we understand. And understanding, real understanding, is something that no algorithm can capture, no pattern can replicate, no system can fake, not because of any technical limitation, but because understanding is grounded in something deeper than computation. It's grounded in consciousness itself, in the felt experience of comprehension, in the irreducible quality of what it's like to truly know. And that perhaps is the one thing that will always separate the thinker from the thought, the understander from the understood, the human from everything else we might create. Not because we're better, not because we're better, not because we're faster, not because we're more capable, but because we're the ones who actually know what it means to understand, and we're the only ones who can feel the difference.